Math 230, Quest to College. I'm Joe Vasta, and we're going to cover 1.4, which happens to be called barricades, or you can call them blockades. But what we're doing is we're looking for direct routes. We did that last time. But look at the picture. There's a blockade or a barricade right there. That means as you're walking from your car to the library, you're walking down here, this road is closed. Okay, another way would be not drawing that road at all. This part of the road. So how are we to do this? Well, the thing that we cannot use because there's a barricade, we cannot use Pascal's triangle. So let me write that down. Cannot use Pascal's triangle. So that is a big bummer because Pascal's triangle was very quick. Now, before we do this problem, I'm going to give you the puzzle for this video. Can you find a strong connection between Pascal's triangle and Fibonacci numbers? So some of you are like, oh, well, I see Fibonacci numbers like 1 and 2 and 3 and 5 and 8's probably down here. But no, I mean a strong connection. So this one's kind of a tough problem if you've never seen it. And the answer is really, really spectacular. Okay, back to barricades. So how am I going to do this problem? Well, I'm going to do this problem very carefully. What I want to do is go back to my old method of saying, well, how many ways can I stand here at this intersection and not do anything? One way. Okay, and how many ways can I go from point A to this point? One. And how many ways can I go here? One, one, one. Okay, so remember we did this in the last video. Now, how many ways can I stand at A and go up to this intersection? One direct route. And one direct route there and one direct route there. So it almost looks like it is Pascal's triangle, and it would be if this wasn't here, but this is going to mess up the Pascal's triangle. So let's continue with labeling the intersections. Remember what you do for this one, you add the two numbers immediately to the left and immediately below. So 1 plus 1 is 2. And 2 plus 1 is 3. Now, there's a barricade there, but that does not affect this intersection at this point. So I'm going to go 3 plus 1 is 4. 4 plus 1 is 5. Now we're going to move up to the street. 1 plus 2 is 3. 3 plus 3 is 6. And normally we would say 6 plus 4. But look at this. You cannot come from this 4. This 4 is blocked with the barricade. Do you see that? So instead of going 6 plus 4, the only ways you can get here are from over here if you're doing direct routes. So you have to put a 6 there. So this right here, let me put it in red, is your trouble intersection. It's the only part where we're going to have trouble on, where the 4 cannot get through. So you the 6 is the only thing going through, and then now it goes back to normal. 6 plus 5 is 11. Everything else is going to be normal. If you have got one barricade, there's going to be one trouble intersection, and that was it right there. 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 6 is 16. And 16 plus 11 happens to be the answer, which is 27. 27 is the answer. So we cannot use Pascal's triangle, and that's how you do the problems. Now, I know if I were seeing this for the first time, I would like the teacher to do a few examples and make sure I feel comfortable with this. You have 14 of these types of problems in your homework, and once it clicks, you'll see that these problems don't take that long. Okay, let's take a look at problem number 2. I'm not writing the instructions each time, but the instructions are how many direct routes are there from A to B without crossing any barricades. How many barricades do we have in this problem? We have 2 barricades. Now, since you're traveling up and to the right, this barricade's going to affect this intersection right there. And then this barricade's going to affect that intersection there. So as we label numbers, I put those in red so we can slow down and say, whoa, those are going to be our trouble intersections. Okay, where your car is parked, or where A is, you put a 1, and you put a 1 on the intersections where that car is parked for these problems. So now we have, let's continue, we have 1 plus 1 is 2. Okay, so we just do that normally. And normally we'd say 2 plus 1 is 3. But which number cannot get through to this trouble intersection? It would be 2. 2 cannot get through there. So I just put a 1 because the 1 is from this guy. He gets through, the 2 doesn't. Now it goes back to normal. 1 plus 1 is 2. Now over here I have 1 plus 2 is 3. And remember, I can put the 3 anywhere near that intersection. Then I have 3 plus 1 is 4. 4 plus 2 is 6. Okay, now up here I have 1 plus 3, but look, this is a trouble intersection, meaning one of these guys cannot get through, and it's actually the 3. When the 3 goes through, he bumps his head on that. He cannot pass that barricade. So the only number that's getting through is this 1 here. So you put the 1 there. 1 plus 4 is 5, and 5 plus 6 is 11. 11 is the answer to problem number 2. Let's go ahead and do the last problem. And this one's going to be a weird one, and you have something like this in your homework where the barricade is where it's on the street where your car is parked. So the trouble intersection is going to be this guy right here. Yep. Let's go ahead and label the intersections. How many ways can you stand at your car? 1 way. How many ways can you go from your car to here? 1 way. From your car to here? 1 way. Now look, you cannot walk from your car to here directly. If you really wanted to get to this intersection, and you don't, you want to go over there, you would have to go this way, and you would have to go to the left. And so that's not cool. We cannot do that. There's no reason you would even be at this intersection. So I'm going to go ahead and put a 0 there. Now everything else continues as normal. Look, 0 plus 1 is 1. 1 plus 1 is 2. I go up to this next intersection. Okay, look, I have a 0 there, so there's no way I would go there if I'm taking direct routes from A to B. So the 0 comes from up there, and then I have 0 plus 1 is 1. 1 plus 2 is 3. And then same thing over here. There has to be a 0 there, and then 0 there. So there's no business. You should have no business being on this part of the street when you're going from A to B with direct routes. 0 plus 1 is 1, and 1 plus 3 is 4. We could have probably figured out this way if we didn't know anything about labeling intersections, because this problem is a small problem. So look, you could have gone right, right, up, up, up. That's 1. Right, up, up, 2. Right, up, 3. Right, up, right, 4. So we can't always do that. In your homework, the numbers will be bigger for a lot of the answers, but I just wanted to show you that we could count the ways. So that completes the last problem. And now let's get back to this. And I think some of you will find this really interesting. Can you find a strong connection between Pascal's triangle and the Fibonacci number? So what I'm going to do is I'm going to rewrite Pascal's triangle in a weird way. So watch this. Here's the row 0, and then here's row 1. 1, 1. And then 1, 2, 1. So I'm kind of justifying it on the left. I'm kind of moving it all over, so these ones are all in a nice column. So watch this. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. Okay, so where do we see the Fibonacci numbers? Let's take a look at them. If you look at the diagonals, so look at this diagonal right here. That adds up to 1, 2, 3, 4, 5. And you might be thinking, well, why'd you start there? I just wanted to show you that I'm counting the diagonals. Now look at this one right here. That one adds up to 3. And then this one right here adds up to 2. This one here is 1, and your first one is 1. I'm going to be careful with the red, because if I go through the numbers, you might not be able to see the numbers nicely. This one right here adds up to 8, because we have 1 plus 4 plus 3, and then we have 6, 7, 8, 9, 10. This one right here is 13. This guy right here make sure we're doing this right here. I paused because I heard some dogs barking. And I'm like, oh well, what are you gonna do? That one right there. So this is a mistake people make. Sometimes they're like, oh, so this is wrong because it only adds up to 25, 26, 27, 28, 29, 30, 31, 32, 33. So they're like, that only adds up to 33. But remember, it should also grab the 1 that's right here. Remember, this is 1, 8, etc. So this actually adds up to 34. So you do see the Fibonacci numbers coming out of Pascal's triangle. And it's not surprising because Fibonacci numbers are gotten by like adding the last 2. And that's how you generate the sequence. Pascal's triangle is also gotten by adding 2 things. Everything that you get within the triangle is gotten by adding things that are above it. So there is the connection between, a strong connection between Pascal's triangle, Fibonacci numbers, and this completes 1.4. This part right here is not going to be on any exams where you have to make this connection. Make sure you do your homework. Do not save your homework all the way till the night before the exam. And the next section should be 1.5. Have a good day.